Okay, we're going to finish up the chapter here with these 3 videos that are going to be dropped on Sunday. What we're going to be dealing with is how we can predict various options using all these formulas that we have for distance and velocity, acceleration, and all that. There's a lot of ways of manipulating the numbers to come up with new formulas. Now, I'm going to be up front with you. I don't like using different formulas. Some people do. This is why I do this. Some people don't. To me, if you know how to manipulate with algebra, most of the stuff is unnecessary. But some people find some comfort in finding an expression for a particular variable that gives you a formula that you can just plug in and get the answer. So that's what this is going to be all about here. We'll start off with the basics, and that is determining the distance from a constantly speeding up, there's no acceleration, just going at a constant velocity or speed. It's going linearly, it doesn't make a difference which one you use. So we know that the formula for velocity is distance over time, or displacement over time. Again, same thing if it's linearly. Then to get the d by itself, you multiply both sides by t, and that's going to give you d equals v times t. And now the graphical analysis we make for a d versus t graph going at a constant rate creates a rectangle. So let's take a look at that. I get to draw rectangles now. Let's see how well this works. Well, I'm going to be a little concerned here, but let's find out if this is... Oh, look, it's a pretty rectangle. All right. So, and let's make, let's see, the graph for this is going to be an XY graph here. So I'm going to go here, and I'm going to go here. Oh, that's just awful. Let's try it again. That's even worse. Let's try one more time. Pretend like I know what I'm doing. That's about as good as it's going to get right now, boys and girls. So this is the x-axis, and that is time. And I forgot I still have my little bougie there. So let's get this back over here. This is time. And my y-axis here is my y-axis here is velocity, v. Now, because velocity is constant, this is going to be a horizontal line. Let's say in this case that we're looking at 15 meters per second. So it's going at this constant speed. Let's suppose that the time in which this goes, at this point right here, let's say it's 40 seconds. So if I want to find out how to find the velocity, I would go, oh, look, that is a rectangle. And then we all know that the area of a rectangle is length times width. Well, the length here is time, and the width here is velocity, so this is going to be v times t. And as we know, v times t, we've just solved as being d. So, as we would suspect, this is going to be 15 meters per second times 40 seconds. So my answer is going to be 600 meters. Pretty simple, but there's the graphical analysis of it right there. With my nice little rectangle that I'm so proud of. Okay, so what happens at a constant acceleration? Okay, so we're going to look at v versus t again, only something else is going to happen here. So let's take a look at that.